In the previous videos, we looked at being able to solve exponential equations where we have the same base, or we can write it as the same base. So in these videos, what we're going to do is we're going to look at what happens if we can't get a similar base. We could still solve the exponential equation. So we're going to have this 2 to the x plus 13 equals 60. All right, so first thing we do is we try to isolate the exponential term. And in this case, the exponential term is 2 to the x. Let's subtract 13 from both sides. All right, if we do that, we get 2 to the x is going to be equal to 60 minus 13 is going to give us 47. All right, now what I'm going to do is I'm going to introduce a logarithm to both sides, all right, just because logs and exponentials are inverses of one another, okay? It doesn't matter what log we introduce, okay? So two ways I can do this. I can do log 2 to the x equals log 47 using our common logarithm, or I could use ln of 2 to the x equals ln 47. All right, and it doesn't matter which base I use. I'm just using log and ln because those are both calculator friendly sort of operations, because we know that there's a log, common log, and there's an ln in our calculators. All right. So what does that do for us? Because a lot of people would look at that and like, well, you just made it more difficult. Well, remember that rule that we can take an exponent and move it as a coefficient of the logarithm. So now we can rewrite this as x log 2 is equal to log 47, or x ln 2 equals ln 47. And by the way, it doesn't matter which of these two you use, okay? I'm just showing you both because sometimes my math lab might want it as log, sometimes as natural log, okay? To finish this out, we're going to divide both sides by log 2. And one of two answers. We can write this as x equals log 47 over log 2, all right? Another way to write that is to go backwards from the change of base formula. And we could write this as x equals log base 2 of 47. I believe that what I circled is the way that my math lab wants it. But just in case you see it the other way, you know that you can write it both ways by using the change of base formula. Over here, we would divide by ln 2, and x would be equal to ln 47 divided by ln 2. All right, now, we've shown this in previous videos, but I just want to verify that we should approximate the answer, and no matter which way we do it, we're still going to get the same answer for either log 47 over log 2 or ln 47 over ln 2. All right, so in our calculator, we could take our log of 47 and divide it by log 2. All right, and let me get rid of this. And that's going to give us 5.555. All right, so didn't plan that, but it just so happened to be 5.555 to 3 decimal places if I approximated it. Now let's try natural log and see if we get the same thing. So if I do ln of 47 divided by ln of 2, that gives us 5.555. Okay, so either way we do it, we get this approximate answer. And so we should be able to do both. We should be able to get the exact answer like this, or we can get the approximate answer, which in this case is going to be 5.555. So now that we know this technique, what we can do is we can just solve any sort of exponential equation, whether we can get a common base or not. So for example, we have 7 times 5 raised to the 5x minus 6 plus 5. Let's start by subtracting 5 from both sides. And that's going to leave me with 7 quantity, 5 to the 5x minus 6 equals 22. I'm going to divide by 7. And that's going to be 5 to the 5x minus 6 is going to be equal to 22 over 7. Now, we certainly know that we can't easily write 22 over 7 with a base of 5. And conversely, we can't write 5 as 22/7 raised to some power. That's where we're going to introduce a log. Okay, I'm just going to use the natural log because I can. And so I'm going to say ln of 5, 5x minus 6 equals ln of 22 over 7. And then what we can do is, just like we did previously, we can move the exponent of 5x minus 6, and I can just move that in front. So that's going to give me ln, or I'm sorry, 5x minus 6 quantity. Ln of 5 is going to be equal to ln of 22 over 7. Now to solve this, I'm going to divide both sides by ln 5. And so I'm going to end up with 5x minus 6 equals ln of 22 over 7 divided by ln 5. I'm going to add 6, so we get 5x equals ln of 22 over 7 over ln 5. And then plus 6, right? And then finally, I'm going to divide everything by 5, right? So one possible answer I can get for this is ln of 22 over 7 over ln 5 plus 6, all divided by 5. All right, so it's a pretty nasty number, all right, but it is what it is, okay? Of course, we want to try to get an approximation for this if necessary, all right? It couldn't hurt to be able to get an approximation. So let's go to our calculator, and we get ln of 22 over 7 divided by ln 5, and then we have plus 6. All right, and I think we're dividing all of that by 5. So I'm just going to put all of this mess in parentheses and divide it by 5, and that gives us 1.342. All right, just for some reason, if we need an approximation, so maybe 1.342. All right, so we can also try to solve exponential equations that have the natural exponential base. Okay, and these look like they're pretty tough, but actually these are easier than the other ones. So we have e to the x plus 2 plus 5 equals 2. So what I'm going to do is I'm going to start by taking the 5 from both sides and subtract it. So I get e to the x plus 2 is equal to negative 3. Then I'm going to take the natural log of both sides. So I get ln of e to the x plus 2 equals ln of negative 3. All right, now, one thing to note is that e's and ln's are inverses of one another. Okay, and so what this would leave us with is x plus 2 equals ln of negative 3. Right? Now, if we wanted to solve for x, we could subtract 2 from both sides. All right, so algebraically, this would be ln of negative 3 minus 2. All right, but what we always want to make sure of is that whatever's inside of a logarithm is greater than 0. Okay, and clearly negative 3 is not greater than 0. And how do we check that? Well, we just go into our calculator, and we're going to try to get the approximation anyway. So if I go in my calculator and I try ln of negative 3 plus 2, all right, notice it gives me the undefined because this is not a real number, okay? So what that means is that since this is not real, okay, so this is not real, okay, that means that there is no solution to this equation, right? Anytime you get a logarithm, whether it be natural log, log base 10, log base 77,000, and you have a negative inside of that logarithm, that is no solution. Okay, so remember, this is not in the domain. Okay, so we talked about domains of logarithms in a previous video. All right, so again, make sure that we remember that rule. One last example for this video, we have 10 plus 8 e to the 2x minus 3 equals 50 over e squared. Right? So let's see if we can get some sort of common base for this. So at least maybe we can try to simplify this somehow. All right. So what I'm going to do with this is I'm going to start by subtracting 10 from both sides. And another thing I'm going to do is I'm going to write this as e to the minus 2. All right. So I could write this as 8 quantity e to the 2 minus 3x equals 50e to the minus 2 plus 10. Now I'm going to divide everything by 8, and I know it's not going to make it really nice, okay, but it is what it is, all right? So If I divide by 8, then this is going to become e to the 2 minus 3x is going to be equal to, now 50 divided by 8 isn't going to work out perfectly, but we know that there's at least a common factor of 2. So this will be 25 e to the minus 2 over 4. And then 10 over 2 is going to simplify to 5/4. All right. Um, to get rid of the e, we're going to need a natural log on both sides. So I'm going to take the natural log of e to the 2 minus 3x, and then ln of everything inside of here. So that's 25 e to the minus 2 over 4 plus 5/4. E and ln cancel each other out. And I'm just going to scoot down here just because I ran out of room. Right. So we get 2 minus 3x equals this natural log of 25 e to the minus 2 over 4 plus 5/4. And now at this point, what I'm going to do is I'm going to subtract 2 for both sides. Right? Now notice that the 2 is outside of a natural log, so I can't subtract this 5/4 and this 2. Okay, so I get negative 3x equals ln of this 25 e to the minus 2 over 4 plus 5/4 minus 2. All right, and then finally, I'm going to divide everything by negative 3. All right, so divide by negative 3, divide by negative 3. And so one possible answer, although it's not nice, is going to be ln of 25 e to the minus 2 over 4 plus 5/4 divided by negative 3. Negative and negative becomes positive 2/3. All right. Or if we wanted to stick it all under a same denominator, we could have minus 2 in the numerator. Okay, so these get pretty ugly. All right, but this is probably something that's a lot uglier than you probably solved in my math lab. But I just wanted to show everybody an example of something that doesn't look like it's going to be all that nice. All right, and it certainly isn't, but that's how we would have to go and solve it. Okay, so in our next video, we're going to take a look at 2 more types of exponential equations, and then we're going to move on to logarithmic types of equations.